Hi everyone. Come, let's go with the special function of SCADA system. On the SCADA system, there are two parts to the term SCADA. Already we are seen in previous slide. The SCADA is supervisory control, indicates that the operator in the energy control center also has the ability to control remote equipment. So, data acquisition indicates that information is gathered characterizing the state of the remote equipment and sent to the energy control center for monitoring purpose. The monitoring equipment is normally located in the substation and is consolidated in what is known in the process of remote terminal unit. Generally, the remote terminal unit are equipped with microprocessor having memory or logic capability. Older remote terminal units are equipped with modem to provide modems to provide the communication link back to the energy control center, whereas newer remote terminal unit generally have internet or internet capability. Sorry. So, special function of SCADA system is relays are located within the remote terminal unit and command from the energy control center open or closed selected control circuit to perform a supervisory action also. Such action may include, for example, opening or closing of a circuit breaker or switch, modifying a transformer tap setting, raising or lowering generator megawatt output or terminal voltage. This switching in or out of a shunt capacitor or inductor and the starting or stopping of a synchronous condenser also. The information gathered by the remote terminal unit or communicated to the ECC includes both analog and digital information status indicator. Analog information includes, for example, frequency, voltage, current, and real or reactive power flows. Status indicator include alarm signal, over temperature, low relay battery voltages, illegal entry, and whether switches and circuit breaker are open or closed. Such information is provided to the ECC through a periodic scan of all RTUs. A second scan cycle is typical SCADA system having data acquisition, information display, supervisory control, that means on off, generator functions or stop and start, rise or lower command. Then information storage and result display, sequence of events acquisition, remote terminal unit processing, general maintenance, runtime status verification, economic model, remote start and stop, load matching based on economics, load shedding. It has some control function, monitoring function, exclude of some other functions. First, we have to see control function, control and monitoring of switch devices, tapped transformers, auxiliary devices, etc. This bay and a station wide interlocking automatic functions such as load shedding power, restoration and high speed bus power transfer, then time synchronization by radio and satellite clock signal. After that monitoring function, it has measured and displaying of current, voltage, frequency, active and reactive power, energy, temperature, etc. Alarm function, storage and evaluation of time stamped events. Then protection function. The protection function, always having substation protection function, includes the monitoring of events like start, trip indication, and relay operating time, and setting and reading of relay parameters. Then protection of bus bars, line feeders, transformers, generators. The special function of SCADA system, there are special programs available to perform special functions. If these programs are executed by the computer in the SCADA system, special functions can be achieved as below the list: AGC, contingency, online load analysis, relaying, load shedding, unit commitment. Then this subsystem control function using SCADA system having alarm function, control and indications, data collection, record and display, sequential operation of device with the predetermined time and conditions for operation of various devices. By means of SCADA system, the operator in control center can cause operation in a remote substation. This possible remote operation includes opening and closing of switching devices, tap changing of transformer, that means voltage control, switching of capacitor bank. It also having voltage control, load shedding, that means load frequency control. This is protective function, what I told the previous. This protective function having sequential events, auto reclosing, bus protection, fault distance reporting, backup protection, line protection, transformers, reactor protection, synchronizing checks. Already I told the previous slide. This is control and monitoring functions. This control and monitoring function under the concept of communication technology. The form of communication required for SCADA is telemetry. The telemetry is a measurement of a quantity in such a way so as to allow interpretation of that measurement at a distance from the primary detector. The distinctive features of telemetry is the nature of the translating means, which includes provision for converting the measure into a representative quantity of another kind that can be transmitted conveniently for measurement at a distance. The actual distance is irrelevant. Telemetry may be analog or digital. In analog telemetry, a voltage, current or frequency proportional to the quantity being measured is developed and transmitted on a communication channel to the receiving location, where the received signal is applied to a meter calibrated to indicate the quantity being measured, or it is applied directly to a control device such as a ECC computer. Forms of analog telemetry include a variable current, pulse amplitude, pulse length and pulse rate, with the latter two being the most common. In digital telemetry, the quantity being measured is converted to a code in which the sequence of pulses transmitted indicates the quantity. One of the advantages to digital telemetry is the fact that accuracy of data is not lost in transmitting the data from one location to another. Digital telemetry requires analog to digital, that means A to D, and possible digital to analog. It's called D to A converters. The earlier form of signal circuit used for SCADA telemetry consisted of twisted pair wires. Although simple and economic for short distance, it suffered from reliability problems due to breakage water ingress, and ground potential risk during fault. Improvements over twisted pair wire came in the form of what is now the most common traditional type of telemetry mediums based on leased wire, power line carrier or microwave. These are voice grade forms of telemetry, meaning they represent communication channels suitable for the transmission of speech, either digital or analog, generally with a frequency range of about 300 to 3000 Hz. Then leased wire means use of a standard telephone circuit. This is a convenient and straightforward means of telemetry when it is available, although it can be unreliable and it requires a continual outlay of leasing expenditure. In addition, it is not under user control and requires careful coordination between the user and the telephone company. Then power line carrier that called PLC offer an inexpensive and a typical more reliable alternative to leased wire. Here the transmission circuit itself is most to modulate communication signal at a frequency much greater than the 60 Hz power frequency. Most power line carrier occurs at a frequency in the range of 30 to 500 kHz. The security of PLC is very high since the communication equipment is located inside the substation. One disadvantage of communication cannot be made through open disconnects. When the transmission line is outaged, often this is preciously the time when the communication signal is needed most. In addition, PLC is susceptible to line noise and require careful signal to noise ratio analysis. Most PLC is strictly analog, although digital PLC has become available from a few suppliers during the last few years. 1 GHz. The earlier microwave telemetry was strictly analog, but digital microwave communication is now quite common for EMS SCADA applications. This form of communication has obvious advantages over PLC and leased wire since it requires no physical conducting medium and therefore no right of way. However, line of sight clearance is required in order to ensure reliable communication and therefore it is not applicable in some cases. A more recent development has concerned the use of fiber optic cable, a technology cable of extremely fast communication speed. Although cost was originally prohibitive, it has now increased to the point where it is viable. Fiber optics may be either run inside underground power cables or they may be fastened to overhead transmission line tower just below the lines. They may also be run within the shield wire suspended above the transmission line. One easily see that communication engineering is very important to power system control. Students specializing in power and energy system should strongly consider taking communication courses to have this background. Students specializing in communication should consider taking power system across an application area. Thank you.